Using log properties and review of negative exponents. All right, first and foremost, if you have not watched the video, properties of logarithms, you're really going to want to do so. All right, there's a lot of properties that we talked about in that video that are really important that aren't going to make as much sense. I'm not going to go through them again in this video, so please watch that video. So we're going to use our log properties to simplify some expressions. We're also going to fill in some missing values. We're just going to kind of use log properties in this video. But before we can do that, we really do need to review negative exponents. It won't take long, but we need to talk about negative exponents, or this section is going to be a little bit more on the difficult side. If you remember, if you have x raised to the negative m, this is 1 over x to the m. All right. So if you have x to the negative 2, this is 1 over x to the positive 2. So it's 1 over x squared. X to the negative 3 is 1 over x cubed. Right? I can continue this on forever. You see what the pattern is doing. Right? This is true of variables, and it's true of numbers. I want to rewrite some expressions without negative exponents. Now is a great time to pause the video so you can try these on your own. So if you would like to do so now. I'll let you know these two right here are challenge problems. So pause. All right, let's write these. So x to the negative 8, this is 1 over x to the 8. 3 to the negative 1 is 1 over 3 to the positive 1, which is just 1 over 3. 6 to the negative 3, that's 1 over 6 to the 3. And 6 to the 3, is it 216? It's 216. On the bottom of this page, by the way, I have a lot of the powers that you're going to need to know for this section. 216. Five to the negative 2 is 1 over 5 squared, 1 over 25. Now, these last ones are difficult, all right, because an exponent only belongs on the thing it's right next to. So for this first one, the negative 4 is right next to the parentheses, so it belongs to everything inside of these parentheses. This becomes 1 over 3x raised to the positive 4. And then we would distribute the exponent. 3 to the 4th is going to be 81. So we have 1 over 81. And x to the 4th is x to the 4th. All right, that 3 comes down to the denominator. It also gets the 4th power. In this last problem here, the 3 does not have the exponent on it. It's like this guy's alone. So we have 3, and then x to the negative 4 would be 1 over x to the 4th. And if we multiply these two things together, we get 3 over x to the 4th. It's just really important to know that where your negative exponent is matters. All right, now the reverse direction of that. And this one is really, really important because you're going to be doing this in the problems you have in this section. Going from a fraction like this and then rewriting it as a exponential with a negative base. So you're going to want to know some of these powers. And on the later worksheets, I wrote them in a different order, which is a little easier to read, but it's fine. All right. All of these numbers here are in our powers, are powers you're going to want to know, because when I go to rewrite something like this as an exponential, I need to know what base I'm looking at. So 27, that's 3 raised to the 3rd power. So 1 over 27 would be 1 over 3 raised to the 3. A positive exponent in the denominator is a negative exponent when I rewrite it, not in the denominator. Now would be a good time to pause if you would like to try them. I'll let you pause. All right. Some of these are going to have multiple ways we could write them. So I could write 1/4 as 4 to the negative 1. I'm going to write it differently, but I know that 4 is the same as 2 squared. So this is 2 to the negative 1. Not negative 1, negative 2. 2 to the negative 2. Okay. Or you could write it as 4 to the negative 1. That would also work. 1/64. So you'll notice 64 is on the 2 list. It's also on the 4 list. So you could use 2s, you could use 4s. It doesn't matter. Maybe we should use 4s because it's fun. So 64 is 4 cubed. This is 1/4 cubed, which means it's 4 to the negative 3. So essentially, if you see a square, a cube, a fourth power in the denominator, you are going to write that with a negative exponent, the base with a negative exponent. 216, that's 6 cubed. So we have 1/6 cubed. That's 6 to the negative 3. 25 is 5 squared. This is 1/5 squared. So it's 5 to the negative 2. 1/x to the 4th is x to the negative 4. Right? And that's our review of negative exponents. So having said all that, let's do some of these fill in the blanks. So fill in the missing values to make the equations true. Here are all of our logarithm properties. That'll do it for us. So with this one here, we have log base 2 of 1/27 is equal to blank times log base 2 of 3. We know it's times because two things right next to each other in math means multiply. So if these are being multiplied, and I look at all my rules here, look at this guy right here. Look at number 5. The exponent comes down in front, and we have that kind of like in front thing going on down here. If we can rewrite log base 2 of 1/27 as something with an exponent, then we could fill in this blank here, right? So log base 2, now 1/27, right? 27 is 3 cubed, which means that 1/27 is 3 to the negative 3. Equals blank log base 2 of 3. Now, using rule number 5, I can take this blank and move it up to the exponent. And we get this statement here. Log base 2 of 3 to the negative 3 is equal to log base 2 of 3 to the negative 3, right? So I want those insides to be the same. Put some parentheses on there. So it's negative 3. For this next one here, log base 4 of 11 minus log base 4 of 9. Subtraction on the outside is division on the inside. So if these are the same base 4, we have 11 minus 9, so that's going to be 11 divided by 9. Rewriting this guy, we have 2 log base 9 of 5 is equal to log base 9 of blank. Well, we can bring that exponent up here. And then we get log base 9 of 5 squared. And that would give us log base 9 of 25. If we put 25 in here, we have a true statement. For this one, log base 3 of 8 plus log base 3 of what equals log base 3 of 56? Rule number 6 says multiplication on the inside is addition on the outside. And this works in both directions. So addition on the outside becomes multiplication on the inside. So essentially, we're looking at log base 3 of 8 times something is equal to log base 3 of 56. That means that 8 times something is equal to 56. So what do we multiply 8 by to get 56? 7. 7. All right, so that's some fill in the blank type problems. You'll see some of those. Let's look at these other ones, which are just evaluating without using a calculator. We're just going to do it by hand. This looks kind of scary. I promise it's going to be okay. One important rule that you're going to need to use here is, where are you? This guy right in here, number 4, but not in that form. If we go back to that first video that we did, the one right before this one, remember that ln of e to the x is equal to x, right? Copy. Paste. This is the base e equivalent. So when I look at something like ln of e squared, ignoring the 4, right? It's tempting to want to bring the 4 up as an exponent, but just ignore that for now. ln of e squared should be equal to 2, right? That's this guy right here, but instead of x, there's a 2. The ln e cancels out, and you're left with just the exponent, right? So this guy right here is 2. And this guy over here, the ln e cancels out. You just left with 9. The 4 comes down. So we have 4 times 2 plus 9. That's not bad at all. That's just 8 plus 9, which is 17. Boom. Right? This works because ln is log base e, right? Log base e of e squared. It falls right into that rule number, what did I say, 4? Yeah, 3, 4. Falls right into rule number 4. Ln is log base e. Now, that doesn't work when we have something like log base 3 of 2, because these guys are not the same base. 3 and 2 are not the same number. So if we wanted to evaluate something like this, I would start thinking about, well, I know to get something out front, I have to bring an exponent down. So I can go that reverse direction and take something in front and bring it up. So I'm going to bring up. I get log base 3. Let's use blue. Log base 3 of 2 cubed minus log base 3 of 72. Ooh, that got a little weird there. 2 cubed is 8, so we have log base 3 of 8 minus log base 3 of 72. Subtraction on the outside becomes division on the inside. We have log base 3 of 8 divided by 72. Be very careful not to do 72 divided by 8. It's always first number divided by second number. So the minus sign tells us this guy is in the denominator. And we'll talk more about that soon. All right, so this would become log base 3 of 8 over 72 becomes 1 over 9. And 1 over 9 log base 3 is 3 to the negative 2, right? 1 over 9 is 3 to the negative 2. Here, now we have something that follows the rule we have. The rule is log base b of b raised to the whatever is the whatever, right? Now we have log base 3 of 3. These things can cancel. Now we're left with negative 2. And that's our answer. All right, so that's using our properties of logs. We're going to continue using these properties of logs The next video, we're going to talk about expanding logarithms. So taking logarithms and breaking them up into a bunch of pieces, and then we'll talk about combining logarithms. And this will all come together. All right, see you in the next video. Bye.